Okay. And so I've just sent a message on the meetup link so that people can know to not wait for the stream. And just want to do the same on Facebook. Okay, good evening everybody and welcome to our first online meetup. As you can see, we're still trying to figure it out, and we're asking very nicely for everybody to make sure they're on mute. Otherwise, Philip is going to compete with whomever's kids are the loudest in the background. And without spending any more time on this, I am going to hand you over to Philip, and I'm going to mute myself. If you have any questions, I think you can type into the chat window.
Yeah.
And Philip can see that, and we'll use that as a way to tell him how we feel about what he's doing. And let's see what he has to offer. Thank you for your time. I just want to find the right button to mute.
All right, I'm going to start sharing my entire screen. Okay, so I hope you guys can see my screen. I'm going to start the presentation. So thank you for your time. I know it's a public holiday, and yeah, it's late at night, so thank you for joining. Some of you might have seen this presentation before. I did give it the first time about a year ago already in, I think it was Java Cloud Conference. So if you have seen it, it hasn't changed that much, but the underlying example or API that I'm going to show you has changed quite a lot. So for the past, okay, so let's start off with the agenda. I'm going to start off by telling you a story, more specifically my story, about how I got to GraphQL. And sorry, I just need to admit some people in the room here. Sorry, admit. And then we're going to look at GraphQL in general. Then we'll look at the MicroProfile specification. Then I'm going to show some examples on small array implementation. And
exactly. Hello. Hello. Can you hear me now?
Hi, you can go on mute, please. Thank you. Where am I? And yeah, if there's time, we'll look at some of the stuff we're busy working on for the future. Right. So starting with my story, and hopefully this will give you some context and you can relate. I was working at a big insurance company, and I'm sure you'll all know who I'm talking about soon, or at least one of the two. And this insurance company, we did short-term insurance, we did health insurance, life insurance, employee benefits, employee wealth management, and all sorts of insurance-related things. And all of these business units was actually operating as a small company on its own. And they had their own IT systems and their own CIO. And then we dealt with the client usually via a broker, or via the call center, or you can log onto the website and help yourself, or later we've built a mobile site. And these are also small little business units or companies of their own with their own IT systems and their own CIOs. And where I was working was right in the middle. Now, our job was to make sure that the client is happy, because dealing with your insurance company is usually not a very positive experience. Right? If you have to speak with your insurance, you usually bumped your car, or your TV got stolen, or you're sick, or you're dead. So it's not usually a good interaction with your insurance company, and it's also not very often. So you usually forget about them until something bad happens. So our job, where I was working, was to engage the client in a positive manner more frequently. And the way that we've done that is that we created a profile of every user, which we then score, and then based on that score, you get some benefits. And we obviously was a department on our own, with our own systems and our own CIO and so on. And the way in which we've done this scoring of this user is we would integrate with an event like a sporting event, or we integrate with your watch or the gyms to see how fit you are, and then based on your fitness we give you some score, and based on the score you get some benefits. Or we link up with your car, we can see how you drive. If you drive nicely, you get some points. We can even link up with your bank account, see the transactions that you've made, and make sure that you are financially well. Then we use that score to give you discount at a shop, right? So either discount at a shop, or discount on flight tickets, or at a coffee shop, or we also had our own online store, and so on. Right, but the point of this is that we had to do quite a lot of integration. We had to integrate with all these third-party providers of data, and then we had to integrate with these providers of benefits. And we had to integrate with all of these other small companies inside this company to be able to show the profile to them, because they need to see the profile to serve the client better. Now, when I started there, which was already a few years ago, obviously there was legacy systems in place, like there's with any big company. And a lot of this integration happened with FTP, some SOAP services, some even straight RMI. A big part of the system is built on the AS400, another part built on Java. And we decided when I got there that we're going to modernize the system. And we want to make sure that our new APIs that we're going to build is going to be cloud ready, it's going to be API driven, and it's going to be well documented. So we decided we're going to build REST APIs. It's going to be awesome, and it's going to solve all of our problems. So the first thing that we did was the website at that time was busy rebuilding their website. And we said, we will build you a profile service, which will give you back the profile of this user. So we would obviously talk to the user. Just see, I think I need to let somebody in. Yes. We're going to talk to the user, and we're going to score the user. So we're going to integrate with these guys, and then we're going to send the data back. Now, I'm going to show you some code. This is obviously not the code of this company I'm talking about. This is just an idea of plus minus how it would have looked like. So obviously, if you've worked with REST before, and we specifically use JaxRS, but it's similar in Spring Web, to create a REST endpoint, you can just annotate your method with @get and @path, and then have a path variable. And then obviously we will return a profile object, which is what we want to give back. This will be marshaled to JSON, and it's fairly easy. A profile itself is just a plain old Java object. It contains a person, and it contains a list of scores that this person has. So the document that's been marshaled over the wire back to the client is quite big, because in our case, if we go back here, the person was we actually got that out of the AS400, which was maintained by a different team that maintained the person, and it had like 70 fields on. But we didn't mind. We included all the fields, and we include the score, And then the web team would have gone and picked up the parts that they want to be able to build their web page and display it on the screen. They were using portal technology. It's a server-side technology, so it was a server-to-server call, and it worked quite well, and they were happy. At that same time, we started building a mobile app, and the mobile team wanted to make use of this REST call because they wanted to show some of the information on the mobile app. However, they didn't want to download or make a call to the 70 plus fields, and they only want to show the person's name and surname. So we said, no problem, let's go read page 2 of the REST manual. And we came across Hatios. It's awesome, and it's going to solve all of our problems. So what Hatios say is, rather than returning the 70 fields plus the score, just have a link to where the document is available. Now you can decide how fine-grained you want to break up these links to other parts of your return. In our case, it would have been something like this, because this is the 2 systems we're talking about. So you would make a call, get this back, and then you'll make a call to that person URL to get the person back, and you'll make a call to the scores to get the scores back. In our case, we didn't really save any data. We just made the client make 3 calls to get all of that data. So the mobile team wasn't really impressed with that. The web team wasn't impressed either, because they had to change their system and make 3 calls and also get no benefit. So then we said, okay, what's next? BFF, which is not best friends forever. It's a pattern called backend for frontend. And what that pattern say is that we'll keep the web team as is. They will make a call like they do currently. The mobile team will have to create a small backend for their frontend, hence the name. Sorry, letting somebody in. And then that backend will make a call as the web team does, sanitize the data and send the result back to the phone. So that between their backend and their phone, they can actually decide what they want to stream down. Again, they weren't, obviously the web team was happy, the mobile team not happy, because they don't want to build backends. They don't have the infrastructure or the knowledge to build it, and they're just building the front end. So what did we end up doing? We created a new method, a REST endpoint, called it Profile Light, and created a new POJO called Profile Light, which returns exactly what the mobile team wanted. So both the teams was happy, and we can continue. At that same time, we had a third-party vendor that built our online shop, and they were changing CMS products underneath, and they wanted to make a call to this new REST endpoint they've heard about to also show the profile on the online shop. However, they want to they're actually using some client-side technology, some JavaScript library, so they want something similar to the mobile team. However, they also want to include the status. So they want profile light, but also status. Now, following the pattern that we've done up until now, we now have to do something like this. Profile light with status, create a new POJO, populate it with exact fields that they're interested in. And we just realized at that point that this is not a scalable solution. We can't build a new endpoint for every consumer's small little needs. So we started toying with an idea of doing something like this, where we go back to the original get profile, but allow the user to pass in as a query parameter the fields they want to include or exclude, or both, and then we will try and figure out which part of profile are they actually interested in. I'm sure this would have worked, but it would be very difficult to document, first of all, and to use, because now it's fine for a basic POJO, but if it's a complex object that has a list of other objects that has another object that has the original object, it gets very difficult to, with some sort of a dot notation, configure exactly what should be included and excluded. So we realized at that point that the problem that we have is basically the problem of overfetching and underfetching, or even worse, the combination of the two. Where overfetching is where we fetch way too much data and the client needs to filter out the parts that they don't want. Or underfetching is that I didn't get enough data with my call and I need to make a subsequent call. to get more data. And then obviously the combination of the two is when I underfetch and then overfetch. We also realized that this is just the beginning. All of these departments are busy modernizing their systems, and they are starting to ask specific things from us. And we cannot actually scale by building an endpoint for each of these every time that they want something. So we went back to the drawing board. Let's quickly see if there's any questions so far. Can you guys see the screen? I see somebody said that they can't see the screen. Okay, so back to the drawing board. Now we've already discussed Atios, and we've already discussed best friends forever. So what happens if you Google queryable REST? And somebody wants to get in, admit. So if you Google that, one of the top results will be GraphQL. It is awesome, and it's going to solve all of your problems. So a little bit of history on GraphQL. It was a project started by Facebook. They've open sourced it recently, 2015. It is just a specification, so there's no real code. It's just a spec. It's been positioned by them as an alternative to REST, even though I believe you can use the two together. It's been described as declarative data fetching, which is solving the exact problem that we have. And they specifically started doing this with their increase in mobile usage, because it is specifically the mobile usage that drives this, making sure that the data that goes over the network is optimized, because that is still the slowest thing in the actual life cycle. And they had a variety of different front-end frameworks that they had to cater for, not only different mobile apps, mobile web, also different browser applications. So this also allows them to do rapid feature development, because it's not a situation like I've described now, where every time that a new consumer wants to come on board, they have to first have a meeting with us to tell us what they want. We have to build a new endpoint, take that live, and then they can start using it. Sorry, just letting somebody in. Right, so like I said, it's been publicly available since 2015. They actually started working on it since 2012. So it's not brand new technology. It's fairly new in the Java world. Some of the benefits that we're going to look at, there's much more, but it's solving the data fetching problem, the overfetching and underfetching that I've described now. The development speed for the consumers, it's much faster, and it actually comes with a built-in schema. So you have a type system and a schema built into GraphQL, where with something like REST or JAX-RS, you have to combine it with something like OpenAPI or Swagger to be able to describe and create a schema for your endpoint. So this is a URL, how to GraphQL. It's a very nice site that will take you through the basics of GraphQL. I can highly recommend it. If we look at our example, what we would have done is we would make a call to the profile service, and that will return us something which will point us to the person service, which we can make a call, get the person back, understand the score ID to use, go to the score system, get that back, combine the data, filter out what we don't want, and display it on the screen. This is the problem we're trying to solve. With GraphQL, I can make a call to the server, tell the server exactly what it is that I want, and the server returns exactly that. Which means if a mobile do the same thing, they can ask for something smaller, or a smaller subset of what we showed just now, and then they get a smaller subset back. So every consumer can ask exactly what they want, and we'll give them exactly what they want. Some of the concepts, I'm not going to go through all of them, but some of them that we're going to touch through the rest of the presentation on GraphQL, just so that it makes sense for you, is that we're going to talk about some operations. The first one will be queries, and the second one will be mutations. So if you think of a traditional CRUD application, queries would be the read part, and mutations would be everything but the read part. So queries is just asking for data, and mutations is every time the data changes. There's also a concept of subscriptions. We're not going to talk about it today, and it's also not yet implemented by MicroProfile GraphQL. It's still on our to-do list. And then there's a bunch of objects inside GraphQL. The first one is a type. A type is basically an output. So every time that you ask for something, or even the output of a mutation, will be some type that comes back. An input is what I provide when I ask a question. And then we get interfaces, which is very similar to Java interfaces, enums, which is similar to Java enums, and scalars, which is similar to primitives. And all of these three could be a type or an input. And then a complex object can also be a type or an input. The schema, like I said, GraphQL comes with a schema. It's actually fairly readable. You can, even though it's built so that a machine can read it, you can see here that I have a type of an address and a type of a credit card, and I have two mutations, delete person, that takes in an input of an int that is not nullable, and it returns a person. So it's kind of readable. And I'll show you a bit more of this a bit later. The other nice thing that GraphQL has is the concept of introspection, which means I can look at myself. So I can use GraphQL to query GraphQL. So in this example, I'm asking the schema to give me all the types, but only give me their name, description, and kind, and that's what I get back. So that's quite nice to be able to actually ask myself some questions about myself. Okay, is everybody still with me and happy? And let's see if there's any questions. Cornel, if anybody, I don't see the questions. If anybody asks questions, will you interrupt me, please? And I can just look at it. Okay, so the third part of this presentation is then talking about the specification that I've been working on for the past year and a half. So I hope by now most of you have heard or at least played with MicroProfile. MicroProfile is a Duke Choice Award winner, and it's an umbrella specification that specifically targets enterprise Java for microservices type architectures or cloud-based type architectures. So the APIs under this umbrella specifically targets to solve the issues or the problems that comes with distributed microservices type architectures. 3.3 is out. This is an old slide, so this still shows 3.2. And this is the APIs underneath 3.2. I don't think there's a new ones on 3.3. It's just updating the ones that's there. And then MicroProfile is not yet under the GraphQL is not yet under the MicroProfile umbrella. It's a standalone API. So the MicroProfile process basically works like this. If you want to add a new API to MicroProfile, you start by playing in the sandbox. So that's where you will do a POC or some examples, or define the problem statement, and then go to the MicroProfile community. And sorry, just letting somebody in. And going to the community and basically showcase this sandbox. And then depending on the outcome of that, you might move towards a standalone API. You first have to release as a standalone API before you can go back and say, this is the uptake. This is how many people is using this. This is what we have. Can we be part of the umbrella? So that's kind of where we are at the moment. We released the first version of MicroProfile GraphQL earlier this year. And we're working on the next version, and we'll soon go back to see if we can get to be part of the umbrella specification. It will still be usable in all the MicroProfile servers. From Red Hat side, it will be part of Wildfly and Quarkus. It will be part of Open Liberty. I know Helidon from Oracle is working on it, and I'm pretty sure it will be part of Tommy and Payara as well. So the process, or what does it mean to be a MicroProfile specification? First of all, there'll be a spec document, which is typically ASCII doc, which will output some PDF or HTML, and you can go and see the first version of the spec at that URL. Then it's a set of APIs or Java interfaces or annotations mostly, which is what the developer will code against or use. It's a bunch of tests. We use TestNG that an implementation can use to make sure that they implement the specification correctly. And then to be able to release the first version, you have to have a compatible implementation. And the one that I will show you today is SmallRye from sponsored by Red Hat. And there's already another implementation as well, which we'll talk about a bit later. Okay, so let's move on to the actual example. So the example I'm going to show you, you should be able to get it running on your own machine fairly easy. So I'm going to actually start a brand new checkout so that you can see how easy it is. We're going to look at this example, the one that I've described in my scenario. And then I'm going to compare it to REST initially. And then I'll show you how you can just move your REST or enhance it to also have GraphQL. So this is a REST endpoint that will get the profile back as we've described. It's a plain old get with a path parameter of person ID. You can see the @ operation that is actually coming from the OpenAPI specification, which would allow me to build a OpenAPI schema definition for this REST endpoint. So I need two APIs to be able to do what we're going to do with one API in GraphQL. And in this case, I'm just basically getting the person from some person system and the score from some score system. This is all just in memory just to make it easy. And then I combine the two and return the profile. Under the covers, JaxRS obviously takes the profile plain old Java object and marshal it to JSON. So to do it in GraphQL, you can see it's actually pretty much the same. The code is the same. I'm changing some annotations. So I'm basically just saying @query, which is coming from the MicroProfile spec. I can add a description if I want to. That will end up in the schema document. And the rest is exactly the same. Then I just say go get the profile and return it. And now I have a queryable endpoint for profile. Okay, so let's go look at the first demo. I'm going to actually start off by actually just checking it out. So I'll just go to desktop. Yeah. So I'll do clone. You can do this yourself. At the moment, this example still points to a snapshot version of SmallRye because I'm busy fixing some stuff. But you can check that out as well. I'll show you a bit later how to do that. Sorry, just letting somebody in. No? Oh, here's a question. Sorry, let me just quickly look at this question. Could you add REST and GraphQL annotation same function then? Yes. Andrew, yes. The answer is yes. Whether you want to do that or not, that's maybe a different question, but technically you can. I didn't in my example because I specifically want to kind of show the differences. Okay, so once you've checked it out, you can just do maven clean install. That will just build it. And then we'll go to person example. And then we can do maven wildfly. I'm just running it against wildfly, but it should work against any application server. So what this will do is if you don't have wildfly installed, or it doesn't even matter, it will go and find wildfly, install it for you, deploy this application on top of it, and I actually use a small library called JFaker to fake some data. So even after it starts up, we will have 100 people in our test database. So once it's done, you'll see you can go to localhost 8080, and we can start with our first demo. So I'm going to actually show you this as well. So this is the this is where you can find the example, GraphQL example, to check it out yourself. I've documented as well as I can to show you everything I'm going to show you now. All the examples we're going to go through is here as well. So after it's started, you can go to, let me just see where I want to open this. Localhost 8080. This will show a static page. And we'll first look at the JaxRS or REST endpoint. So this is Swagger UI that is just basically a UI on top of the Open API that's been generated due to MicroProfile Open API. So you can see here, here's the profile service as an example. So what while we were using REST, this is kind of what we had to do. We had to go say, go get me profile 1. That's the first option. And then that will get back quite a big JSON file that I need to now filter out what I want. Or I can follow the Hatios approach where I say, well, get me person 1. That will get me back something small. And then if I only want the person, I now know where to find the person. Or if I want both, I know where to find the score. Then I need to combine the two. Then I need to filter it. Right, but this is that same application. So what we can do in GraphQL, there's a front end very similar to Swagger UI that allows you to execute some GraphQL queries. So we're just going to use that. So here's my first query. I'm going to go query profile full, and you'll see I have code inside here because of introspection. So this JavaScript front end actually uses introspection to go and see what is possible. You can also see the actual schema here. So you can see the full schema, and you can see nice documentation. So if we do profile full, I can say, okay, I've got profile. I can see the description. I can see what a profile entails. It has a person has an address has code and lines. So it's quite nice, the documentation that comes with it. So in this case, I'm asking for person ID 1. I only want back the surname of the person, and I want the scores of that person, right? So now my data set that I get back is much smaller, and I get exactly what I want, right? Versus the REST example, which was quite big. So that's our first example. So what we realize now is that what happens if I don't ask for score, and we could be in a situation where person and score, like my example, was actually two different systems, and score was on this old system that was very slow. So even if the query comes in and the person didn't ask for score, I shouldn't make a call to the score system because it's penalizing you for nothing. So I basically don't want to do this. I don't want to do the score necessarily by default if somebody asks for the profile. I only want to do it if they've asked for the specific score field. And what you can do in GraphQL is you can do something like this, where you can move that to a method of its own, mark the parameter as @source, pass in the object that is being returned here, and we will stitch the two together. And you can do it for more than just two. You can split it up as many as you want. So what will happen now is that let's do demo 2. So what I want to do is I want to show you the log file of the system. So we're gonna close this one and this one. So we're gonna basically make the first call like we've done now, right? If we look at the log file, we'll see that we've got person 1 and we made a call to the score system. If I clean it up and I don't want to do the scores. Now it shows scores. I saw it was twice in the previous one as well, which means there's a bug in my smaller implementation. So we are working against the snapshot smaller and we're busy making some changes in that. But what should happen is that it shouldn't make a call to the score system at all. So you shouldn't see the score line there. And we can try and we can actually try and go back to the released version. That should actually fix it. But because of time, I'll just continue. You can obviously do it yourself at home and check it out. Right, so what that allows us to do is it allows us to stitch together a bunch of endpoints to build up the graph that we are interested in. And what we realize now is that we actually don't need a profile object at all. I can just have a person object and a score object, and then I can stitch the two together using GraphQL. So in our case, the person Pojo does not have a field or property name score on it, but I want to be able to allow people to kind of merge them together if they want, and I can actually do that with GraphQL. So what we're going to do next is we're going to have a query that returns a person, and then we'll say, and if you ask for scores, we will actually stitch that on, and we will go and make that call and return that with a score. So we should be able to do, we might get the same problem as this one, but it will still work. So I can actually here go back and say I actually want person, and let's do person ID 2, and I only want back the names and the surname. And now you'll see I have a score field right on person, and now I get an error. Yeah, that's what happens if you still make code changes. We can actually quickly switch to version, to not use the snapshot version. So what I'm going to show you is my IDE. I'm going to stop this server. And I'm just going to change not to use snapshot, because 20 minutes before this I was still working on this. So let's do this. Right. And I'm basically just doing a wildfly run again. I'm just doing it outside of my IDE. Any questions? Sorry. This we also build a Maven plugin that allows you to actually generate the schema on build, and that's the stuff I was adding right now before this. So it won't work on 1.1, obviously. Okay, so hopefully this will go better. Okay. So back here, let's do this code. This is not nice. Let's try something else. Yeah, I remember this. So there's another front end called GraphQL, which we're going to use because I had to also fix this specific front end I've shown you now. So anyway, this should work. So let's go person, and we want person ID 2, and we want back names and surname, and now score, which is not on the Java object. Now score, we want back the name and value. Right, so then I get only that. So what this allows me to do is to actually stitch stuff together that's not in Java together, but on the boundary on GraphQL, I stitch them together. I can actually also do something like this if I want. So I can say person 2 is this guy, and then also give me a person, let's make it 3, and then I do the same person with person ID 3, and maybe here I only want back the name. Right, so I can actually ask multiple questions in the same call, which is quite cool, and I can ask for different responses based on what I'm asking. This should also have fixed the other issue that we've seen. So you'll see now my scores only print out once, and obviously now, if I don't ask for scores, it won't print out. Right now, it's only getting the 2 people. So I didn't make that expensive call to the score system. Right, so let's move on. Then we can obviously do collections. I've shown like you can nitpick specific people. One of the benefits here is actually to do something like collections, because in getting 70 fields back in the rest, when you do 1 person, that's potentially still manageable. But if you ask for multiple people, that quickly becomes quite a lot of data. Now let's just do this. Let's say I only want the names and the surnames, then that's all I get back. So the result is still much smaller than it would have been in the rest. Okay, so up until now we've kind of spoke about queries mostly. We've queried the data, but then you can obviously also do mutations. So update or create, update, and delete. So I'm actually just going to copy that from here because that's too much to type out. But as an example, this mutation will now create a new users. And you'll see in my Java code, it's just add mutation and then the method and add mutation. So you can, again, do add description if you want to add a description and things like that. Right, so I'll create a person. I only give it a name, but I'm asking back the ID, name, surname, profile picture, and website, which obviously won't be set because I haven't created it. But I did get an ID back, which is now the generated ID, which will allow me to actually now do a update because I have the ID. So now I can actually set the rest if I want. You can obviously do it in 1 call. I just wanted to show you an update. And now my surname, profile picture, and website has been set. And then obviously a delete. I added a specific delete method where you can just pass the ID in, mutation, but I can do a delete. In the delete, I still return the person that has been deleted, and I asked for that data. So it returns it, but if I delete again, it won't get anything back because I'm deleted. Right, so that's mutations. Now, the other nice thing that MicroProfile GraphQL have that I think it's much better than REST is the way in which exceptions or errors are being handled. So the first type of error is a validation error, like this example where I'm actually asking for something that doesn't exist, and the schema can immediately tell me it's not correct. So as an example, this does not exist. There's not a field on scores. So if you go back here, let's do a query again. So we'll say person or person ID 5. Right, so I can ask for names, surname, score, and blah, which is not a field. And you'll see already here, I will know that it's not correct because this GraphQL also uses the schema to actually validate what you're asking. But if I go ahead and still execute it, you'll see that I now get nothing back in data. So I didn't get any data back, and I get my error back. And you can have multiple errors back. So depending on how many mistakes you made, it will show all the errors. Right, so now I get 2 back. So it'll tell me exactly where it's this that I made a mistake. So that's the first kind of error. And this error hasn't even hit your code. So if you go back to the Java code, this is a mutation, but it hasn't even hit the code that you wrote because it fails before we make this call to your code, which is quite cool. And then the other type of error is when it's a valid query, but something went wrong. So in our case, we're going to simulate that the score system is down. Now, the way that I've done it is to just add another scores field onto the person, but then just throw an exception simulating that the score system is down. So if we go back here we'll do what we wanted to do, name and value, right? So this will work. But now let's say your score system goes down. To simulate that, we'll do that. So now I can still get back the person because there's nothing wrong. I've got that data. I just don't have the scores data, and I got the error back for what is the problem with the scores. So depending on how complex your graph is, you can get quite big partial results back and your partial errors. And depending on your system, you might still survive that, which again is definitely better than just a plain failure like we get with REST. Okay. So you can obviously do more complex graphs. Like I said, we've shown how we can link score and person together. I can link something else to person, or more things to person, or I can link something to score, which means I have a person is linked to score is linked to, let's say, event. In our case, this was actually real. So every score is made up of an event. So to get a specific score, you did 10,000 steps, or you went to the gym, or whatever that specific event was. So let's say you browse on the web and you get deeper into the details of the score, and you want to show the actual events that made up the score. We can do something like this now, where we have a source field scores on top of person, and then I don't know if you can see my mouse, but you should see this right here. And then I can add an event field on top of score. And again, depending on what the client is asking, that's what we'll see. So we can actually close this one. Yeah, so this one we want to clear a bit. And going back, sorry, I just want to find my bearings. So what we say now is we'll go back to score. So this will work. And now I can also go and say, well, give me the events. Let's do the action, the date, time, and the value. Right, so now I can see this score is made up of me driving, and that's my score. That's the date that I was driving. And again, it will only call that method in the case that I've asked for it. When I didn't ask for it, it didn't call it. Right, so far so good. The other thing that we decided to support on this specification as part of version 1 was JSON-B support, because that's something that you get out of the box with JAX-RS at least. You can annotate your POJOs with JSON-B to manipulate the data. As an example, I've shown you the date time now in the previous example, but what if you wanted to format that date to something like this, which is more readable? So I've added another field called when, and then I just add the normal JSON-B date format that you already get with JSON-B. So back here, if I rather use when and not date time, I will get back the formatted. And you can also see the documentation again. It will show me the format that I get it back in. And now I get it nicely formatted. And that is similar for any other JSON-B annotation, like a number formatting, like as an example, salary. This will print out the currency value in South African Rand in front of this number. I can rename the salary field to monthly salary in GraphQL only using JSON-B property. I can hide something, so it's not part of JSON, it's not part of GraphQL, but it's part of Java. And then depending on where I put this annotation, it will either apply to both input and output, so type and input in GraphQL, or if I only put it on the getter, it will only apply to the output. If I put it on the setter, it will only apply to the input. So it's very powerful what you can do. You can also, if you're not using JSON-B, you can use the GraphQL annotation for this, which is very similar. So it does exactly what these three does. It just, we called it name to rename the field, number format, and at ignore, and then obviously date format. So you can use that as well. It does exactly the same as the JSON-B one. You can also, using the GraphQL annotation, you can actually do something like this, where you format the number inside a list, like we've done here. Or you can use not null on a field, or you can use not null inside a list, which means the list itself is nullable, but if the list exists, the fields inside cannot be null. Right, another annotation that you get is a default value. So as an example, you can create a query where you can ask for all the people with a specific surname. And if the query does not contain the surname as an input, we will use Kruger as the default value. You can also annotate your types. Up until now, I haven't shown you that because you don't have to do it. But if you want, let's say the person object, the POJO, you can actually annotate with add type, and then you can rename it. Otherwise, we'll just use the class name. Same with add input, same with enum and interface. But you don't have to do any of those because we will just figure it out based on your query annotations. Right, and then the last demo I want to show you is introspection, and we've spoken about this a little bit, and this is where you can use GraphQL to actually query the schema itself. So as an example, I can do, I can say I want to talk to the schema, I want to get back the types, and I want their name and what kind they are. Right, and then I get back, there's an action enum, there's an address object, there's an address input object, and so on. So that's also quite handy if you build tools that supports GraphQL. Right, so let me just see if there's any questions. Where's that thing? Okay, let me quickly actually go through the questions because I would rather answer the questions than continue with this. Okay, so Dave, hello Dave. I see you asked a question about performance. I haven't done any performance testing myself between GraphQL and JaxRS. It's on our to-do list. You can definitely run into performance issues if you go mad with the fields. And if every field is going to be a source field that needs to be stitched together, that's a method call. So yes, if you do it wrong, you can get bad performance. I think the same applies for JaxRS though. I'm not sure if that answers your question.
Oh, I've seen GraphQL in action on the JavaScript side, and it comes to the power is if you're talking to multiple data sources. That's when you get the power. If you've got all your data in one database, then you are doing multiple queries where one query may suffice, and it might mean doing a bit of extra work to figure out how to best satisfy that potentiality.
Yeah, and in our case, it actually won't do multiple queries in a database case. If let's say in our case, the person example, that'll be one call to the database to get the person back. You will get all the fields back though, and then we'll nitpick the fields that we care about. What we're working on, and I'll get to that later in the presentation for version 1.1, is this context object that is request scope. So on every request, you will be able to inject a context object, which will give you context of the question being asked. So you can inject it where you make your SQL call, optimize your query, and then when we ask, only the fields that we care about will be brought back from the database.
That's lovely, because then, so then the SQL can look at the context and see, oh, I don't need to do this join.
Yeah.
And it can go hand in hand. And one of the questions was in terms of overhead and join performance. I think basically what you have to decide is that eventually all systems, your IO is your worst performer. So if you can avoid IO, then you're winning. So a bit of introspection and to avoid I/O is always useful. And then obviously, if you combine that with caching, which is another powerful part of the specification.
Yeah.
I don't know how
So
much you've done on that, but maybe touch on that.
Yeah, so if you actually go to the small RAI implementation now, you'll see a pull request still being open that that is added to cache. So it's not part of version. It's not being mentioned in our spec at all. Our implementation, small RAI, will have it once we release the next version, which will be 1.02. We'll have caching in. I think the biggest issue is when you don't have multiple systems, like in my example where score was on a Java system and person on AS400, then you shouldn't really do the at source, right? Because if they're all in the same, let's say, database or NoSQL data store or whatever, you can rather optimize that query to get back what you want. And because I think that'll be faster. I quickly want to answer this question. Neil asked, in a real-world application, how does GraphQL impact the load on the system? I don't know how it impacts the load. What I can say is, at least theoretically, we'll have to do some. We have to get some people to use this in real-world applications to answer that. But like I said earlier, especially with mobile applications, which makes a call over a dodgy 3G network or even worse, edge network, the slowest thing is your network. So what we're trying to optimize here is exactly that, is what we stream over the network should be optimized. And similarly, if we go to microservices and a way in which two services talk to each other, if you start getting hundreds of microservices talking REST to each other, sending a bunch of data over your network, which you discard on the other side because you're only interested in 3 of the fields, you can optimize that by actually asking for what you want.
Well, and as we know, a network doesn't scale linearly.
Yes.
If you double the size of your packet, you are going to feel the pain, and at some point it gets horrible. Anybody who's worked on large systems will know that.
Okay, Katleg asked, how would you control access to data? And some systems might not be permitted to access certain data. How would you control that on GraphQL? It's a very good question. It's one of the things that is harder to do in GraphQL because in REST you have multiple endpoints, and every endpoint you can secure accordingly. So you can build an endpoint that is allowing in the people that you want to give access, where with GraphQL you have one endpoint, and that endpoint is queryable. So what we're going to do in the next version of the specification, and it's already on the issue list, and we've discussed it already a little bit, and some implementations might actually come with this built-in even on version 1, as we will use the normal Java annotations as far as we can to make it easy for developers. And you should be able to annotate a query with the Java security annotation and the roles allowed. And then we will fail that query, or if it is a stitched query, like an at source, we will fail that part of the query and return partial results with the security exception. That's all work in progress, so don't quote me on this. We might change how we do security, but we are looking at it at the moment. I hope that answers your question. Right, so I don't know how much time we have. I think we have until 1:30. So I'm going to continue. The example I've shown you now was using small RAI, and the first part was the cutting edge snapshot version, which I'm still working on, and we're fixing some stuff there. The released version is 1.01, so if you play with it, maybe use that one rather than the one that I've shown you. The small RAI one will end up in Wildfly and in Quarkus. And then there's another implementation called Speaker, which is actually a library that exists before we started this process. And a lot of the concepts that we have in the specification comes from that library. And I'm sure that library will be included in the implementation of some of the other application servers. Small will also be part of Open Liberty. And you can actually, just out of interest sake, let me show you this. You can go to, in fact, let me go here. There's a link at the top. If you go to the SmallRye GitHub page, you can actually get running yourself. There's even a runner project here, which allows you to manually run using GraphQL all the test cases of the specification. So it's quite nice to play with that as well. And it's similar to my example. You just do -profile wildfly and it will start a wildfly profile. So do go play with it. Okay, where's my... Okay, so I'm going to quickly go over on what are we busy discussing at the moment for version 1.1 of the specification. And obviously all of that is work in progress, so don't quote me, and we might change. And if you think it should change, come and join us. We have a Gitter channel, we have meetings, we chat on GitHub. So the first thing that we're adding is a client, because I've shown you GraphQL, which is just like Swagger UI. It's just that this is how you can test your endpoint type client. It's not really a usable client in a production system. So at the moment, with the first version, if you want to make this cool, you have to build up your own HTTP post with the payload that I've shown you in GraphQL. Post that to the endpoint and get the result back and pass that again. That's obviously not something that we want to do. We want to make it easier. So we have a client, and there's two parts to this client. There's this part that we don't know what to call it yet. It might be low level, it might be dynamic, it might be fluent, it might be something else. And if I want to make a query like this, where I basically say, get me all the heroes in New York, and I want back their name, current location, and the team they're affiliated with, I will do something like this, where I have this builder type pattern where I can say, I want to do a query, add a root field, and again, that might change to something else. And then you can see that the structure here, the arguments that I add, the fields that I add, is basically the same as this. It's an easy way to build up this, where obviously if you have to do this with HTTP post, it's quite a lot of code. Underneath, this guy will do and make the HTTP post to the endpoint and get the result back. And if you get the result back, you can, very similar to JaxRS client, if you've ever worked with that, you can either ask for a string version of it, which will just be the JSON string, or you can ask for the JSON object, which is a JSON P object, or you can give me the type to which I should cast this to, and I'll give you a type back. The other part of the client is, again, we don't know what to call it yet. It will be something like high level or type safe, which is built on top of this low level client. And it will work very similar to MicroProfile REST client, if you've ever looked at that. So as an example, if I want to do this query, where I say, get me all the heroes in New York, and I want their name and superpowers, I will go and create an interface with the queries that I'm interested in this case, only all heroes in. I'm going to pass in a city, and I'm going to get back a list of superheroes. I'll mark it with GraphQL Client API. I will not create the implementation for this API. The system will do it underneath. I then create a superhero object, which represents my view of the superhero and not the server's view. So if the server has 70 fields and I care about these two, this is the two I put in my Pojo. And then I can just use normal coding. So I inject my API and I make a call on top of it and I get back my superheroes. So this is a more high level type safe type client. So both of those are actually, we're pretty far ahead with this. You're welcome to go and read up on it in both the spec side and in SmallRye, where we start playing with the implementation. Some of the other things this we've mentioned is this concept of a context. So either we'll call it request info or request context or something. This is an injectable object that you can inject per request and get information on the question that's being asked. And this is so that you can optimize downstream somewhere, the database or the NoSQL or whatever your query part is. Even though you can page already by manually coding in a an offset and a limit at the moment. What we want to do is make paging easier. So, sorry, I thought somebody is coming in. So making paging easier by just allowing you to do add pageable on your query method, and then we will add the offset and limit fields for you. And this is obviously then some session scoped where the offset will kind of page as you go. Security, we've also mentioned. We're busy talking about how we'll do both authentication and authorization. We will potentially at least support JWT, the spec from MicroProfile, so that when something request is authorized with a JWT token, we will translate that back into the roles and responsibilities that we can then use. And then, as I said, we'll potentially do something like add roles allowed on a method level. And then obviously support for all the other APIs. We actually already have support for metrics and small write, so you should be able to measure your calls. And we'll add tracing and fault tolerance, and as I said, JWT, and any others that make sense. And then there's quite a lot of other issues that we're looking at. You're more than welcome to go and look at it and do pull requests and help us. And that is the end of my talking. You can find me online if you think of a question later. You can get the slides using that QR code, the example that I've shown you, and then I'm taking questions now. Let's see if there's any questions. Where's that?
Yeah, so we've got a question. Are you able to write integration tests when creating an application which consumes your endpoint? Or would you use a normal mechanism for testing REST?
Yes, so I mean, we obviously using quite a lot of testing in the actual implementation to not only run the TCK, but also our own testing in the implementation. We use a combination of Arquillian to deploy your app and test against that. Then it's just plain old HTTP calls that you make. In other cases, I'm using Rest Assured because, again, it's just a post. Going forward, once the client is out, you can just use that client to make the call. Some parts of the implementation we test against, it's just plain Java. So we just make a call, a plain Java call, it's just a normal JUnit because we just didn't boot it up inside a containers that serves it over HTTP. So yes, definitely. You can also see there's integration. I can't remember if we call it integration test or just integration in SmallDry where we test the metrics part. So yeah, definitely there's multiple ways to test the endpoint. Is there any other questions? You don't have to ask via the chat as well. You can unmute yourself and we can just talk.
I see there was one that asked if it runs stuff in parallel.
Dave, it definitely can. It's going to depend on the dependency of your graphs. In my example, I couldn't ask for the scores if I don't have the person because I need some idea of the person to get the scores. So anytime that you want to stitch stuff together where the one depends on the other, like I've shown, then it doesn't make sense to do it in parallel. But there's no reason why it can't run in parallel. And underneath, all the implementations that I know of MicroProfile GraphQL is a library called GraphQL Java, and they allow you to do parallel fetching depending on the dependency graph of the fields. I don't know if that makes sense, but yes, but it happens actually under the covers.
There was also a question about reactive support, and if I'm not mistaken, that's also on the cards on that GraphQL Java library.
Yeah. So from our side, what I'm actually busy on working now is the Quarkus extension, and there I'm using Vertex. So in the example I've shown you now, I've just used Servlet, but in the Quarkus we'll definitely have a Vertex endpoint. How reactive it's going to be, I'm not sure yet, but yes, it's definitely possible. And the spec itself actually doesn't even have to run over HTTP. We just said that for version 1 we will support HTTP. But whether I ask that question over HTTP or some other messaging system, it doesn't really matter. So we could start supporting other transport layers and not just HTTP, and which might be more suited for some reactive type. I don't know if that answers your question, Dave. Or was it Dave? I don't know who asked it. Anything else?
Well, there's a comment from Andrew that said Facebook actually uses RSocket instead of HTTP, which is obviously inside the data center. You want to optimize that, and RSocket's growing. I made a comment that I don't know if everybody saw, but I came to my surprise discovered that Neo4j actually has GraphQL embedded. So you can stand it up and you can just start playing, and you can create types and mutate them, and it'll store them as objects in the graph and translate the queries into GraphQL queries. And they keeping working on it. So it's not just something they did for the sake of providing a tick box on a feature list. They're actively working on improving it, and it looks like it's keeping up with all the other GraphQL developments. So, and that's the other thing is your downstream can just be another GraphQL client query that you make to build up your source, and that's when you want RSocket or something efficient.
Yeah. So obviously from our side, we also still working on the spec. We drive the priority of features based on feedback from the community, and we actually get some nice community involvement as well. The client, for instance, is totally been done by outside of a vendor. It's not Red Hat or IBM or Tommy Tribe or somebody. It's just a consumer that's helping us with that. And we specifically focus on code first, where obviously Neo4j is a product. You also see GraphQL now popping up in API gateways. So a lot of people that promotes the schema first type development, like where you would have built your WSTL file and generate your SOAP, or build your Swagger and then generate your REST endpoint. You can also build your GraphQL and then generate the endpoint. This is not something that this spec handles. We only do code first, very similar to JAX REST. But GraphQL in itself it's popping up everywhere, and I'm pretty sure we will see it, being used as the de facto standard for integration between microservices fairly soon, replacing REST. That's my personal opinion.
Yeah, it's not going away.
Yeah, it's definitely not going away.
Any questions from anybody else? Well, then I can say thank you all for coming. Thank you, Philip, for engaging discussion, and we are keeping our eye on this, and exciting times ahead. And the end result is that systems will be more interoperable because of this.
Yeah, definitely. I'll send we've recorded the session. I'll send it out. And like I said, if anybody has more questions, find me online, ping me, join our effort to get this done. We own GitHub, so it's all open source. Yeah.
Okay.
Thanks.
Good night, everybody.
Cheers, everyone. Thanks for your time.